This periodic table will be very much useful for the chemistry student as well as for the chemist. The periodic table is nothing but a tabular display of elements. It is a tabular display of elements. The atomic masses of the middle element, it is always equal to the arithmetic mean of atomic masses of the first and the last element. So in the Mendeleev periodic table, he considered the horizontal row as a period. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Periodicity College, Temple of Excellence, Mysuru. My dear students, today I am here to introduce a new chapter called Classifications of the Elements and Periodicity in Property. This is the third unit in your first PUC Chemistry. So before going to understand this chapter, let's see the weightage for this chapter. So the total weightage for this chapter is 4 and we can expect 2 questions. That is specially from the part 1, we can expect a 1 mark question. That is specially from the question number 4, we can expect from this chapter. And also from the part C, the 3 mark question, especially the question number 19 can be asked from this chapter, and the total weightage for this chapter is 4. So we can easily earn 4 out of 4 from this small unit in your first PUC Chemistry. So before going to understand this chapter, let's see what are the content we are going to discuss in this session. In this session, we are going to discuss with the introduction to the classification, then the significance of classification, and also we are going to discuss with a brief development or the history behind the development of the periodic table. My question is, or for the chemistry students, it is necessary to understand the periodic table. Because for each and every religion, we have a special book. For Hindus, we have a Ramayana, like for the Christians, we have a Bible. Is it right? And also for the Muslim, we have a Quran. Is it right? Like that, for the chemistry, we have a book called as a periodic table. This periodic table, which helpful for the chemist to understand how the elements which has been placed or displaced in a periodic table, and also to study each element in the periodic table, this periodic table will be very much useful for the chemistry student as well as for the chemist. Let's see what is the necessary or why do we need to classify the element. Let's see now. If you classify the elements systematically, that will give a clear idea and the information regarding the properties of the element. Is it right? So, this property may be a physical property or it may be chemical property. And also, once you classify the elements systematically, we can predict the neighboring elements also, because almost all these elements has been placed with their similar physical and chemical property in the periodic table. So, this is a small introduction to the classifications of the elements. Now, we'll see the significance of classification. The periodic table is nothing but a tabular display of element. It is a tabular display of elements where each element should be arranged in the increasing order of their atomic number, and each element should be arranged with the similar and a chemical property. Okay. The systematic classifications of the element which provide the idea and the information about the properties of the element. So if you arrange the elements or if you see the periodic table, you can clearly understand that most of the element which the chemist has been placed, they have a similar physical and a chemical property, and we can predict the next element in the periodic table. And also this classification which provide a interrelationship of the scientific facts. So in addition to this, which are all the scientific facts will be there, which provide a brief interrelationship for that. And also the layout for the periodic table to demonstrate the recurring chemical properties. Not only this periodic table which gives us similar physical property, which also help us to understand which role the element which shows a different chemical property with the different chemical reactions. And also, the arrangement of the element would rationalize the known chemical facts about the element and predicts the new one for the undertaking present further study. So, if you are looking into the modern periodic table, you can clearly say that most of the elements, they have a similar physical property and a similar chemical property. So, based on that property, we can predict the unknown elements which has been placed in the periodic table. This is how the chemists, they started discovering these elements in order to place this element systematically in a table. Hence, it is named as a periodic table. Hope you understood with the significance of the periodic table. Now, let's see which role the scientists, they have contributed their own idea to arrange these elements systematically in the periodic table. The first and most famous scientist is John Darwin. The John Darwin was the first scientist in the year 1780 to 1849. He gave a better idea for the classifications of the element. Let's see what is that idea. In 1829, the Darwin, a German scientist, he made some groups of the three elements. Each is based upon the atomic masses and he called them as a trait. So, what he considered? So, he is the first element after discovery of the maybe 30 elements of that, on that time. He is the first scientist. He grouped the three elements and he called them as a trait. He called them as a trait. All these three elements of a trait, they are similar with their physical and chemical property. He says that when he grouped the three elements, he grouped the three elements based upon their similarity of their physical and chemical property. And he proposed the law of traits. He proposed the law of trait. According to that, the atomic mass of the middle element of a trait is always equal to the arithmetic mean of atomic masses of the other two elements. So, what does he say? According to the Darwin, he says that the atomic masses of the middle element, it is always equal to the arithmetic mean of atomic masses of the first and the last element. Let's see how did he say this law based upon his own prediction. Let's see with an example. Here, I have listed out a few elements which has been discovered on that time. Okay. So, he says that especially Darwin, he grouped the three elements and he called them as a trait. And he says that the atomic mass of this middle element can be obtained by adding the atomic masses of the first and last element. If you take out the arithmetic mean of this, this will become a atomic mass of the middle element. This is how, based on this similar characteristics of the particular elements, he grouped them as three elements in the form of trait. So, this idea was given by the Darwin. You can clearly understand from this table, he grouped lithium, sodium and potassium. So, the atomic mass of the sodium can be obtained by adding the atomic mass of the lithium and the potassium and it is divided by 2 which gives rise to the atomic mass of the sodium. Like that, he also considered the calcium, strontium and barium. Here also for the strontium, the atomic mass can be obtained by adding the calcium and also with the barium and it is divided with the 2. Like this, he grouped the three elements and he called them as a trait and according to him, remember, always the middle element having the atomic mass that is always equal to the atomic masses of the first and the last element with the arithmetic mean. This is how our Darwin, he says about he displayed the elements based on its own law. And remember, he called them he is the one person, he grouped the three elements and it is called by the name called traits. Okay. Next, we'll see the contribution of the another great scientist that is known as Newland and his law which is known as law of octaves. Let's see what was its contribution. In 1865, the John Alexander Newland noticed that when elements are arranged in an increasing order of their atomic weights, every eighth element had the property which is similar to the first element. This law, which is also known as law of octaves. According to the Newland, he says that when he arranged the elements in the increasing order of their atomic masses, every eighth element has the same properties of the first element. Okay, so this was an observation which has been made by the Newland, and he says that the Newland could arrange the elements in this manner up to the calcium out of total over the 60 elements which were known on that time. So during the 1865, only 60 elements will be discovered by the scientists. So up to the calcium, this law will be applicable. Let's see with the table, then we will understand how we arrange the elements. Okay, this is a Newland law of octaves. According to that, he arranged the elements, and he says that when he arranged the elements in the increasing order of their atomic mass, every eighth element should have the same properties of the first element. Here you can see that he arranged the lithium, barium, boron, carbon, nitrogen, oxygen and fluorine. Isn't it? After that again sodium. He says that the properties in the first element to the eighth elements are one and the same. So he says that the properties of the first and the eighth elements are one and the same, and he compared this law to the law of octaves. Octaves means if you see the Sarigamappa, if you see in the music, there are 8 letters will be there. Is it right? Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. The 8th letter, that is Sa, again it is repeated to the first letter. So he considered based on this law, and he says that every 8th element have the same properties of the first element. And remember, this law will be applicable only till calcium, even in the modern periodic table also. If you see the modern periodic table, like this we have arranged the elements in the increasing order of their atomic weight, but up to the calcium it is only possible. Okay, later on that, based upon the several limitations after this, they found out the many mistakes in this law, and many scientists, they have left this law for the some time. Later, another scientist called as Mendeleev, he come to the existence, and he explained the periodic table in its own way. Let's see what is the contribution of the Mendeleev. Next, a breakthrough in the classifications of the elements come in the form of Mendeleev work. He is a Russian chemist, and he proposed the following things regarding the classifications of the element. He says that the list of the elements which are known at that time, which is not necessarily complete, which means to say that on that year, especially at the year 1834, only 60 elements will be discovered by the scientists. Still more discoveries are going on. So it is not completely done by the scientists. And also, it is expected that the properties of the element should be a systematic, hence the properties of the unknown elements should be predicted. While he arranging the element, he says that the properties of the every element should be similar in nature. If any unknown element which is not discovered, that should be kept as a vacant space for the discovery of that particular element, and that should have a similar property with the other element. So this was a two postulate was proposed by the Mendeleev after the Newland. And also he says that according to him, the properties of the elements are the periodic functions of their atomic weight. According to him, the properties of the elements are the periodic functions of their atomic weight. Atomic weights are very important while classifying these elements according to the Mendeleev. Let's see with the Mendeleev periodic table and how did he classify the elements. Let's see now. After that, we'll see the merits. Okay, this is a periodic tables of the Mendeleev. You can see that this is a way he arranged the element. So let's see the main features of this Mendeleev periodic table. So in the Mendeleev periodic table, he considered the horizontal row as a period and a vertical column as a group. He considered horizontal rows as a period and vertical column as a group. And also, the properties of a particular period shows a regular gradation from the left to right, which means to say that the properties of the elements are always increases from left to right. And also, all elements in the particular groups are chemically similar in nature and they shows a regular gradation in the physical and the chemical properties. So, what does he say? He says that the horizontal rows are known as period. Vertical columns are known as group. And how does the physical property will be increases? From left to right. And also he says that the chemical property which is also increases with the gradation. So let us discuss the entire periodic table which has been proposed by the Mendeleev. So this is a Mendeleev periodic table. You can see that this is horizontal rows are known as a period and vertical columns are known as group. Okay. Here in the first group he placed the hydrogen. Okay. In the next period, he placed the lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So, based upon the atomic weights of the elements, he arranged the elements in the increasing order of their atomic weights. You can see that the atomic weights will be started increasing from left to right. And also, if you see this Mendeleev periodic table, you can clearly understand that some of the vacant spaces which is also created by the Mendeleev. Why he left the vacant spaces? Because he already come to know that most of the element which is not discovered at that time, maybe it will be comes under in this place. That is why, he left the vacant spaces for the discovery of the unknown element. Especially on below the aluminium, he left the spaces and he called them as a eka aluminium. He called them as a eka aluminium. And also just below the silicon also, he left the one of the spaces and he called them as a eka silicon. He called that space as a eka silicon. This eka aluminium is for the discovery of the gallium and eka silicon for the discovery of germanium. So this is how the Mendeleev, he planned himself to create the vacant spaces for the discovery of the unknown element, because this unknown element should have a similar property with the other element. That is why at the middle in the periodic table he left some of the vacant spaces. This is all about the just introductory part to the history of development of the periodic table. In the next session, we are going to discuss with the modern periodic table and who discovered the modern periodic table, what all the things will be there, we are going to discuss in the next session. Till that, take care and we will meet you in the next session. Thank you.